What if reality itself cannot be fully described from any single point of view? Not because our senses fail, not because our instruments are limited, but because reality possesses more aspects than any single observation can ever capture. Jain philosophy gave this a name 2,500 years ago. Anekantavada. Before the definition, discover this yourself. Look at something nearby right now, an object, a surface, a color. Now shift your angle slightly. The shadow changes, the color shifts, the edge looks different. Now ask, which view was the real one? All of them. None of them completely. This is not a trick of perception. This is not a limitation of your eyes. If this is true at the level of particles, it changes what every observation you make actually is. Quantum mechanics confirmed this in 1927. Niels Bohr called it complementarity. No single measurement captures the whole. Jain philosophy had been investigating the same structural territory for over 2,000 years. Two investigations, 2,500 years apart, the same structural boundary. This video maps three Jain philosophical concepts against three quantum field concepts, with primary sources from both traditions. Here is what this video maps precisely. Jain philosophy is one of the oldest continuous philosophical traditions in the world. Its foundational thinker, Mahāvīra, lived approximately 599 to 527 BCE. Mahāvīra was not primarily a metaphysician. He was an investigator of the nature of reality, specifically the relationship between the observer and what is observed. Three Jain philosophical concepts map against three quantum field concepts with extraordinary structural precision. Anekantavada, the many-sidedness of reality, maps against quantum complementarity and wave-particle duality. Syadvada, conditional predication, maps against quantum superposition and probability amplitudes. Paramanu, the Jain atomic theory, maps against the quantum field's elementary particles. This video maps all three. The first parallel. In 1927, Niels Bohr formalized the principle of complementarity. A quantum system does not have fixed properties independent of how it is measured. Measure it one way. It behaves as a wave. Measure it another way. It behaves as a particle. Both descriptions are accurate. Neither is complete. The choice of measurement determines which aspect of reality becomes visible. Bohr's conclusion: reality at the quantum level is irreducibly multi-aspective. No single description captures the full nature of a quantum system. Here's the steel man this comparison requires. Bohr's complementarity emerges from quantum mathematics. Anekantavada is an epistemological philosophical doctrine. They operate at different levels of description. One makes specific quantitative predictions. The other makes philosophical claims about knowledge. These are not identical disciplines. The structural parallel is this. Both reach the same foundational conclusion about the nature of reality, that no single perspective is complete, through entirely different methods. Jain philosophy arrived here through rigorous philosophical analysis of how any observer relates to any observed object. Quantum mechanics arrived here through measurement of subatomic particles. Two instruments, one structural boundary. The Tattvārtha Sūtra, composed by Umāsvāti, approximately the 2nd to 5th century CE, formalizes Anekantavada precisely. Reality has infinite aspects. No single statement can exhaust the nature of any real thing. Every description is valid from its own perspective and partial from every other. Bohr published his complementarity principle in the journal Nature in 1928. Jain philosophy had been investigating the same structural territory for over 2,000 years. Before we move to the second parallel, test this directly for 20 seconds. Think of someone you know well. Now consider, every person who knows them holds a partially different description of who they are. None of those descriptions is wrong. None is complete. The person exists as an infinite set of perspectives, each real from its own angle, none exhausting the whole. Anekantavada. This is not a limitation of knowledge about them. This is the structure of what they actually are. Quantum mechanics says the same thing about an electron. Syadvada adds the second dimension, what Anekantavada implies about how we speak about reality at all. Syadvada, the Jain doctrine of conditional predication. Every statement about reality must be qualified with the prefix syat, meaning, in some respect, conditionally, perhaps. Not as an expression of uncertainty, as a rigorous philosophical recognition that every claim is true from a particular standpoint and partial from every other. The 7 modes of Jain predication, 3 of them, with their quantum parallels. In some respect, it is the wave function assigns a real probability to each possible position of the electron. In some respect, it is not. Every other position is simultaneously real with its own probability amplitude. In some respect, indescribable. Before measurement, the electron's actual position cannot be stated in classical language at all. 3 modes, 3 quantum parallels, the same structural description of potentiality. The wave function is a superposition of possibilities, each real with its own probability amplitude, none definitively actualized until measured. Syadvada. In some respect it is. In some respect it is not. In some respect, indescribable. The quantum wave function. In some respect here. In some respect there. In some respect. Before measurement. Both and neither simultaneously. 2 descriptions of the same structural relationship between any observer and any system being observed. The quantum field has elementary particles, the irreducible constituents from which everything observable is built. Jain philosophy described them approximately 1,700 years before the Standard Model. They called them Paramanu. Umāsvāti's Tattvārtha Sūtra, verse 5.25. Paramanus are the fundamental constituents from which all observable matter is constructed. They cannot be divided further. They exist in combination or isolation. They carry qualities, touch, taste, smell, color, but in their isolated state, these qualities exist only as potentials, not as actualities. Now consider quantum field theory. The quantum field is not empty space with particles moving through it. It is a sea of excitations, each elementary particle a vibration of its corresponding field. The electron is an excitation of the electron field. The photon is an excitation of the electromagnetic field. Before excitation, before measurement, the qualities of the particle exist as probabilities, as potentials, not as actualities. Jain Paramanu. Qualities exist as potentials before they are actualized in combination. Quantum field. Particle properties exist as probabilities before they are actualized through measurement. two descriptions of the same structural relationship between potentiality and actuality at the most fundamental level of matter. The Buddhist tradition adds a third direction, and adds the dimension Jainism doesn't explicitly name. Buddhist sunyata, emptiness of inherent existence, and Jain Anekantavada arrive at the same territory from different philosophical approaches. Where Jainism says, reality has infinite aspects and cannot be captured from a single perspective. Buddhism says, phenomena have no fixed inherent nature at all. They arise dependently through conditions. Anekantavada says, reality cannot be captured from a single perspective. It exists as an infinite set of aspects, each real from its own angle. Both describe the same structural fact. There is no fixed, perspective-independent, measurement-independent nature to things. Quantum mechanics describes this at the level of elementary particles. Two ancient traditions describe it at the level of philosophical principle. Three independent investigations, the same structural conclusion. Now let us test this directly. The investigation Jain philosophy prescribes begins with the observer, specifically with the claim that any observation is partial by nature. Close your eyes if possible. Bring to mind any belief you hold with confidence. Not for debate, for investigation. Ask, from which standpoint is this view accurate? Not whether it is true or false. From which position, angle, context, is this view accurate? Now ask, from which other standpoint might the same situation appear differently, and also accurately? Anekantavada does not say all views are equally valid. It says all views are partial, including this one, including everyone. The quantum measurement confirms this at the level of particles. Jain philosophy mapped it at the level of all knowledge. Rest there. Let the breath return naturally. In the early 20th century, quantum mechanics discovered that no single measurement can capture the complete reality of a quantum system. Measure it as a wave. You lose its particle nature. Measure it as a particle. You lose its wave nature. The complete picture requires multiple incompatible measurements, multiple perspectives, none of which alone is sufficient. Approximately 2,500 years earlier, Jain philosophy described this as the fundamental structure of all reality. Not as a limitation of instruments, as a property of existence itself. Anekantavada. No single perspective is complete. Syadvada. Every statement must be conditionally qualified. Paramanu. Fundamental constituents whose qualities are potentials before actualization. Niels Bohr described complementarity. Umāsvāti described Anekantavada. Mahāvīra investigated the relationship between observer and observed. None of them knew what the others had found. All of them found the same structural boundary. Whether one accepts their conclusions or not, the question they all reached is unavoidable. Is the incompleteness of any single observation a failure of our instruments or a feature of the reality those instruments are trying to measure? Ancient wisdom, quantum mystery, direct knowing. This is quantum gnosis,